Hello, ma'am.
Good
Ma'am?
evening, sir.
Ma'am, good evening.
Yeah, sir. Wait, sir. I'll make you as a host. You please continue, sir.
Okay.
Yes, sir. You can continue, sir.
Yes. Good evening.
Good evening, sir.
Good evening. So we have the last colligative property. We will finish off with the last colligative property, and next week, next Tuesday, one more class. We'll finish with this chapter today, and one more hour we need to complete this chapter, and then we'll start with a new chapter. All right. Now, the last colligative property, what we are supposed to learn is called as depression in freezing point, or it is cryoscopy, or it is also called as decrease in freezing point. Depression in freezing point or decrease in freezing point, it's also called as cryoscopy. It is just the same as the ebullioscopy, what we learned it in the previous class, but it's opposite. In case of ebullioscopy, there was an increase in the boiling point. Here, the freezing point, there will be a decrease. Now, freezing point is the temperature at which liquid and solid states of substance are in equilibrium. We take water. Water is in liquid state. Water is in solid state. This equilibrium state is called as freezing point. The temperature at which the water which is in liquid state and water which is in solid state are in equilibrium with each other is called as freezing point. Or it may be also defined as temperature at which liquid and solid states of the substance have same vapor pressure. It also can be defined as the temperature at which the liquid and the solids of the substance, solid states of the substance have same vapor pressure. It is observed that freezing point of a solution is always less than the freezing point of a pure solvent. It is observed that freezing point of a solution is always less than the freezing point of a pure solvent. Now, we will take 1 kg of water. We will take pure water. We'll take 1 kg of water. Now, this 1 kg of water, you cool it to 0 degrees Celsius. When you cool it to 0 degrees Celsius, what happens? The water becomes ice. At 0 degrees Celsius, what happens? It becomes ice. 0 degrees Celsius is minus 273 Kelvin. You know that. Now, the same, we are taking 1 kg of water in another container. We take 1 kg of water in another container. And to this, we add 180 grams of glucose. 180 grams. So 180 grams of glucose is 1 mole. 180 grams of glucose is 1 mole. This becomes 1 molar solution. This becomes 1 molar solution. And if you try to find the freezing point of it, this freezes at minus 0.52 degrees Celsius. See, same. Here also we have taken 1 liter of 1 kg of water. Here also we have taken 1 kg of water. But here it's only water. The freezing point is 0 degrees Celsius. But when you take a solution, 1 molar solution, there is a decrease in water freezing point. The solution freezes at minus 0.52 degrees Celsius. So this clearly shows that a solution has lesser freezing point compared to the pure solvent. If we say, we'll forget about this representation, I will write, if the freezing point of the pure solvent is T0 degrees Celsius, and the freezing point of its solution, the freezing point of its solution is T degrees Celsius, then we know that T0 is greater than T. So this is 0 degrees Celsius, and this is what, minus 0.52 degree Celsius. So T naught, freezing point of a pure solvent, is greater than freezing point of its solution. So therefore, we can write or define depression in freezing point. We represent it as delta TF. That will be equal to T naught minus T. What is the depression in freezing point definition? It's a difference in freezing point of a pure solvent to that of its solution is called as depression in freezing point. It is represented by what? Delta TF. Did you follow what is depression in freezing point?
Yes, sir.
Yeah. So the formula you should remember, delta TF is equal to T naught minus T. What is T naught? Freezing point of a pure solvent. T is freezing points of its solution. So I gave a clear example here. 1 kg of water. I've taken 1 kg of water for a reason I will tell you later. So 1 kg of water freezes at 0 degrees Celsius. 1 kg of a solution freezes at minus 0.52 degrees Celsius. There is a decrease in freezing point of a solution. The sodium chloride and calcium chloride anhydrous are used to clear the snow or the road. So they depresses the freezing point of water and thus reduce the temperature for formation of ice. So water, the snow and if you have to clear the snow on the road, so sodium chloride or calcium chloride is used because when you use sodium chloride or calcium chloride, it decreases the freezing point of water and reduces the temperature of formation of ice. So normally ice is formed at 0 degrees Celsius, but when you add NaCl or potassium, calcium chloride, the freezing point still decreases. Therefore, it reduces the temperature for the formation of ice. Ice is not formed easily. So now the depression in freezing point is determined by Beckmann's method. This method you should remember, the name of the method you should remember. Freezing point can be determined by Beckmann's method and Rast-Camphor method. Study of depression in freezing point of a liquid in a non-volatile solute is dissolved is called as cryoscopy. I told you in the beginning of the class, this depression in freezing point is also called as cryoscopy. Now, important relationship concerning the depression in freezing point. The first one is decrease in freezing point or the change in freezing point is proportional to lowering of vapor pressure. Similarly, in boiling point, delta TB is equal to P naught minus P. We learned it. The same thing here also. The decrease in freezing point is proportional to P naught minus P. That is called as lowering of what? Vapor pressure. The second formula, delta TB, you would have, if you remember, delta TB is equal to Kb into molality. Kb is called as ubilioscopic constant, we learned. Similarly, in case of freezing point, delta TF is equal to Kf into M. What is this Kf? This delta TF is depression in freezing point. Kf is called as molar depression constant, or it is also called as cryoscopic constant. What is this molar depression constant or cryoscopic constant? Now, molar depression constant already I taught you now. See here, 1 kg of water we take and the freezing point is 0 degrees Celsius. We take 1 mole of a solution, 1 molar solution, then the freezing point is minus 0.52 degrees. So the decrease in temperature observed when 1 molar solution is taken is called as depression in freezing point. When compared to the pure solvent, if you take 1 molar solution, how much there is decrease in temperature with respect to freezing point is called as depression in freezing point, or it is also called as molar depression constant, or it's called as cryoscopic constant. Did you follow this? What is cryoscopic constant?
Yes, sir.
Or not? Yes. Now the relationships are same as we learned in case of what delta TB. Here delta TF, depression and freezing point, is given by the formula Kf into W into 1000 divided by M into W. So 1000, or else maybe we can write 1000 into Kf into W divided by M into W. What is this Kf? Kf is called as molar depression constant. What is this W? This W is weight of solute. And what is this M? This is molecular weight of solute. And this W is weight of solvent. So rearranging the term, we can write M is equal to 1000 into Kf into W divided by delta Tf by M. So M you can take here and Tf you can bring it down. So we can calculate the molecular mass of a non-volatile solute using depression in freezing point also. This is another, this molar depression constant I clearly defined. What is Kf? Kf is molar depression constant, and it is defined as elevation in boiling point. So it's a mistake. It's not elevation, it is decrease in freezing point produced when 1 mole of a solute is dissolved in 1 kg of the solvent. Wrongly typed. So freezing point depression, molar depression constant is defined as the decrease in the freezing point produced when 1 mole of a solute is added in 1 kg of solvent. Pure water freezes at 0 degrees Celsius. 1 molar solution freezes at minus 0.52 degrees Celsius. So what is molar depression constant? Delta Tf is equal to T minus, this is what? T naught, and this is what? T, we represent it. So T minus T naught, that is 0 minus of minus 0.52. So that will be again what? 0.52 degrees Celsius. So the decrease in temperature is by what? 0.52 degree Celsius. This is called as molar depression constant. Do not think that since it is decrease in temperature, you will have a negative value for molar depression constant. It is not, because we calculated just now here. Delta Tf is equal to T minus T naught. The last formula which you have to remember in depression and freezing point is Kf is equal to R T naught square divided by Lf into 1000. T naught is normal freezing point of the solvent. Lf is latent heat of fusion of the solvent. Kf for water is 1.86 degree kg per mole. Kf is what? Molar depression constant. So far any clarification? Molar depression constant? Freezing point, decrease in freezing point formula?
No, sir,
No.
no doubts.
No. So we can work out the problems. Are you sure that you don't have any clarification?
Yes, sir.
Yes, sir.
The first question. Just now we learned that sprinkling of salt helps in clearing the snow-covered roads in hills. This phenomenon involved in the process is lowering of vapor pressure of snow, depression in freezing point of snow, increase in the freezing point of snow, or melting of ice due to the increase in the temperature. Just now we learned, so sodium chloride or calcium chloride, when you sprinkle, what happens? There will be a decrease in the freezing point, therefore ice will not be formed. So listen to this. When salt is spread over snow, snow starts melting from the surface because of the depression and freezing point and helps in clearing road. You should remember, when you sprinkle salt on snow, the snow starts what? Melting, because there's a decrease in freezing point, melting from the surface. From the surface because of depression in freezing point and helps in clearing the road. Clearing the road. So remember this. Water freezes at 0 degrees Celsius. Snow is formed at around 0 degrees Celsius. But when you sprinkle a salt or something, what happens? There will be a decrease in water freezing point. Therefore, snow starts melting and it helps in clearing the road. Therefore, the answer for this question is option B. The next question. Volume of cane sugar, 5% solution of 5% glucose.
So
of molar mass 180
Sir,
degrees. Tell me.
sir, can't hear you, sir.
No, no. Now,
So just for some time you are not
Yes,
audible.
sir, now we
yeah,
can.
but there was a call. No, maybe the net was interrupted. I believe. Sorry.
Okay,
Okay.
sir.
Now you can hear. Okay. Now 5% solution of weight per. The molecular mass of sucrose is 342 gram per mole. As a freezing point, 271 Kelvin. What will be the freezing point of 5% glucose? The molecular mass of glucose is 180 grams per mole in water. If the freezing point of water is 273, pure water is 273.15 Kelvin. Now, we should remember delta TF is given by the formula KF into W by M into capital W. We just now learned the formula. What's that formula? KF is what? Molar depression constant. W is what? Weight of the solute, small letter w. All right, small letter w. M is the molecular mass of the solute, and W is the weight of solvent. For cane sugar, what is delta TF? They have given delta TF to be, what's the delta TF? They have not given delta TF. They have given it freezes at what? 271 Kelvin. So what is delta TF? We can calculate delta TF. It is T minus T naught. What is T? Pure solvent. The freezing point of pure water they've given 273.15. Now for the cane sugar, they've given the freezing point as 271. So 273.15 minus 271 is 2.15. So for cane sugar, delta TF is 2.15. That is equal to, they have not given you the KF, so we can write KF. What is that weight they have given? 5% solution, weight by weight. 5% solution means solute is what? 5 grams. Divided by, maybe you can multiply it by into 1000 also. 1000 into 1000 because the formula says 1000. Divided by, what's the molecular mass of sucrose? They've given molecular mass of cane sugar as 342. Into what is the weight they have given? Weight is 5% solution. When I say 5 grams of solute, 95 grams will be what? Solvent. 95 grams will be solvent. We will mark this as 1. Now for glucose, delta TF, what is delta TF? They're asking you to find what will be the freezing point. We don't know. So delta TF is equal to what they've given, 5% glucose, again, 1000 into, what is KF for glucose? They have not given KF. So we write KF. Since it is 5%, again, the weight is what? 5 grams. Divided by molecular mass of glucose is 180, they've given. And what is the weight of solvent? 5% solution means it's 95. This will mark it as equation number 2. So what we can do is we dividing equation 2 by 1. Dividing equation 2 by 1. What will I get? I'll get delta TF is equal to 1000 into KF into 5 divided by 180 into 95 divided by 1000 into KF into 5 divided by 342 into 95. See what happens? 1000 gets cancelled, KF will get cancelled, 5 will get cancelled. So you will have what? You will have the delta TF. This is what? Delta TF by what? 2.15. I didn't mention this, 2.15. So delta TF by 2.15 will be equal to 342. This also 95 will also get cancelled. 342 by 180. So on simplification, delta TF will be equal to 342 into 2.15 divided by 180. On simplification, you will get 4.085 Kelvin. So delta TF for glucose is 4.085 Kelvin. So what's the freezing point of the solution? Freezing point of glucose solution will be T minus T naught. No, T naught minus T, sorry. T naught minus T. So it is what? 273.15 minus 4.085, that will be equal to 269.07 Kelvin. Therefore, the answer for this question is option B, 269.07 Kelvin. Please just observe this. You have understood this? Students, did you follow this?
Yes, sir.
Yes. Ajay, did you follow?
Yes, sir.
The next question, what weight of glycerol should be added to 600 grams of water? What weight of glycerol should be added to 600 grams of water in order to lower its freezing point by 10 degrees? In order to lower its freezing point by 10 degrees. And Kf, they are given 1.86 degrees Celsius per mole. So the formula for this delta Tf is equal to 1000 into Kf into W divided by small m into capital W, weight of solvent. So what is now weight of solute, weight of glycerol to be added for 600 grams of water? So glycerol is a solute. So they're asking W, small w. Small w will be what now? Delta Tf into m into W divided by 1000 into Kf. What is delta Tf they've given? Delta Tf they've given us in lower its freezing point by 10 degrees. So delta Tf is what? 10 into molecular mass of glycerol is 92. Glycerol is 92, CH2OH and CH2OH. I think this is the representation of glycerol. No, it's not this. CHOH and CH2OH. This is the molecular representation of glycerol. So it is 92, and weight of the solvent they've given us 600 divided by 1000 into Kf, they've given us 1.86. On simplification, you will get this as 296.77 grams. So if you add 296.77 grams of glycerol to 600 grams of water, the freezing point will decrease by 10 degrees Celsius. Hence, the answer for this question is around 297. 296.77 is close to 297. Hence, the answer for this question is option B, 297. Followed?
Yes, sir.
Now, this question is a little different from the three questions what we have learned. We will try to understand. It's a very simple question. Of the following 0.10 molar aqueous solution, 0.10 molar aqueous solution, which one will exhibit the largest freezing point depression? Which one will exhibit largest freezing point depression? See, remember this formula, delta Tf is equal to I into Kf into m. I is called as Van 't Hoff factor. This I, we'll learn about Van 't Hoff factor a little later. Van 't Hoff factor. This Van 't Hoff factor is represented as I. All right. Now we also know that in this relation, Kf and m molality is constant. Because for all these compounds, they've given 0.1 molar. Since it is constant, we can write delta Tf is directly proportional to I. So these two are constants because for all the four molecules, they're given as 0.1 molar aqueous solution. Since the concentration is given and which is constant for all the four substances, so we can write Kf is a constant and molality is also constant. Therefore, we can write delta Tf is proportional to I. What is I? I is called as Van 't Hoff factor. Now the question is, of the following 0.1 molar aqueous solution, which one of the following exhibit the largest freezing point depression? So depression and freezing point is a colligative property. So more the number of particles, more will be the decrease in what freezing point. Now in order to understand that, so we can write Van 't Hoff factor for ionic solution. Van 't Hoff factor for ionic solution. Now the first one, they've given option KCl. This KCl will dissociate to form K plus and Cl minus. So therefore, One molecule of KCl gives two particles, ions. I will be what? 2. Vanta factor for KCl is 2. Similarly, if you take B, glucose C6H12O6, glucose will not undergo dissociation. Therefore, no ions are formed. So I will be 0 for glucose. The third is Al2SO4 thrice. This will dissociate to form 2Al3 plus 3 SO4 2 minus. So how many ions we have totally? 2 plus 3. I will be what? 5. So if you take the fourth option, it is K2SO4. It will dissociate to form 2K plus and SO4 2 minus. I will be what? 3. So we just now learned delta TF is directly proportional to I. So for which I is more? For aluminum sulfate, I is more. Therefore, aluminum sulfate will show largest freezing point in decrease in what? Freezing point. Hence, the answer for this question is option C. The answer for this question is option C. Correct? Did you understand?
Yes, sir.
Yes.
Now, if you answer me this question, if you have understood this, you answer me this question. Amongst the following molecule, which will show highest boiling point? Which will show highest boiling point? Just guess me, guess. Let's see whether right or wrong.
Sir, aluminum sulfate.
Very good. Because the same relation goes to elevation and boiling point also. Delta TB will be equal to what? I, proportional to I. Or maybe delta TB, elevation and boiling point is equal to I into KB into molality. The same formula. All right. So here also delta the TB will be greater than I. So this clearly shows that elevation and boiling point will be maximum again for what? Aluminum sulfate, because it gives 3 ions. Therefore, aluminum sulfate will show maximum increase in what? The boiling point. Correct?
Yes, sir.
Yeah. The next question. Wait. The freezing point constant of water is 1.86 degrees Celsius per mole. If 5 grams of sodium sulfate is dissolved in 45 grams of water, 5 grams of sodium sulfate is dissolved in 45 grams of water. The freezing point is changed to minus 3.82 degrees. Freezing point is changed to minus 3.82 degrees. Calculate the Van 't factor of sodium sulfate. See, Van 't factor of sodium sulfate is not that sodium sulfate dissociate to give 2 Na plus and SO4, 3. It's not 3, as we learned in the earlier question. They're asking you to calculate Van 't factor. So in order to calculate Van 't factor, the formula we know that delta TF is equal to I into KF into M. So they're asking you to calculate I. I is equal to delta TF by KF into M. Now, what is delta TF? Now, on substitution, KF into M, molality, M is molality, we can write this formula as delta TF into weight of the solvent divided by KF into weight of the solute divided into what? Not weight of the solute. Now, weight by molecular mass. That's number of moles of the solute, W by M. You work out the formula, then you will know this. So that will be equal to delta TF. They have given 3.82. I will not take it as minus. Minus sign says decrease. How much of decrease? It is 3.82. So 3.82 into weight of the solvent, they have given us 45, divided by KF, they have given us 1.86, into weight of the solute, what they've given, 5 grams, and molecular mass of, so molecular weight of Na2SO4 is 142. 23 into 2 plus 32 plus 16 into 4. So it will be giving you 142. So W by M, number of moles, is 5 divided by 142 into 1000. This is not 100, sorry, into 1000. So on simplification, the answer you'll get is around 2.63. Hence, the answer for this question is option A, 2.63. Just look at this problem, how to calculate the Vanta factor. Go for the next problem later. Understood this?
Yes, sir.
The next question. A solution of sucrose with molecular mass 342 has been prepared by dissolving 68.5 grams of sucrose in 1000 grams of water. The freezing point of the solution obtained would be, it's a direct question. What's the direct question? So delta TB is equal to, delta TF, sorry, is equal to KF into M. That's nothing but delta TF is equal to 1000 into KF into W by M into W. This is the formula, direct substitution. So on delta TF, what you will get? You will get 1000. KF they have given us 1.86, and weight they have given 68.5, divided by molar mass they have given 342, and what is the weight of solvent? They have got 1000. So on simplification, you will get 1000 will get cancelled. So you will have what, 1.86 into 68.5. That will be equal to, divided by what? Divided by 342. Sorry, that will be equal to 0.372 degrees. So delta TF is 0.372 degrees. What is delta TF? Delta TF is T naught minus T. T naught is of pure, pure solvent, and T is sort of solution. So what is the freezing point of pure? It's in degrees Celsius. So pure solvent freezes at what temperature? 0 degrees, and minus of 0.372, the solution. So therefore it will be minus 0.372 degree Celsius. Hence the answer for this question is option A. Did you follow this?
Yes,
Yes,
sir.
sir.
Yeah. Ajay?
Yes, sir.
Next question. 0.5 molar, wait, 0.5 molar, right? 0.5 mole, 0.5 molar aqueous solution of weak acid, HX, is 20% ionized. If Kf of water is 1.86 Kelvin per mole, lowering in freezing point of the solution is. Lowering in freezing point of the solution is. Now, this HX is a weak acid. Now, when we say HX is a weak acid, it will dissociate to form H plus and X minus, partial dissociation. Initially, we have 1 mole of what? HX, and H plus is 0 and X minus is 0. But the degree of dissociation is given as alpha. So from 1 minus X, alpha dissociates because it's a weak acid that doesn't undergo complete dissociation, partial dissociation. Therefore, we write it as 1 minus alpha. So when from 1 mole alpha dissociates means X is what? H plus formed is alpha and X minus formed is also alpha. So therefore, the total is the sum of all this. This is 1 minus X plus alpha, 1 minus alpha plus alpha. That gives you what? 1 plus alpha. So they have given in the question 20% ionized. Now, when I say alpha is 20% ionized or 20% dissociated, sorry, ionized or dissociated, same, dissociated. It means alpha is what? 0.2. Percentage 20 by 100 will be what? 0.2. 1 plus 0.2, that is 1.2. Do you understand how to calculate this?
So once again, repeat
So
it.
therefore, delta TF, yeah. Now, see, initially you are taking 1 mole of HX. This 1 mole of HX is a weak acid. Therefore,
Sir, your voice is breaking, sir.
from 1 mole alpha, yeah, man, my internet is fine. Network is working.
Sir, your
Because of the
voice is
network.
breaking, sir.
Now,
Now it's clear, sir.
yeah, sometimes the network issues are there, no? See, initially you take 1 mole of HX and no H plus is there, no X minus is there. But when this 1 mole of HX is dissolved in water, a 0.5 molar, sorry, here it's 0.5 molar, when dissolved in water, from 1 mole, alpha moles dissociate. Assume that 1 mole, I have 6.023 in 10 per 23 molecules. From that, around few molecules dissociates. That few is represented as what? Alpha here. So when few dissociates, how much of H is formed, how much of X is formed? Alpha of H is formed, alpha of X is formed. Assume that I have 100 rupees. I give you 10 rupees. How much you have? You have 10 rupees. And how much I have? 100 minus 10. So from 1 mole, alpha dissociates. How much of H plus is formed? Alpha forms. And how much of X minus is formed? Alpha. So what will be the total number of ions formed at equilibrium? Total number of ions formed at equilibrium or present at equilibrium will be sum of all this. So it's 1 minus alpha plus alpha plus alpha. So what happens? Plus alpha and minus alpha gets cancelled. What you have? 1 plus alpha. So I will be what? 1 plus alpha. Total number of ions present at equilibrium will be 1 plus alpha. But in the question they've given, it is ionized how much percent? 20% is ionized. So 20% ionized or dissociated means 20 divided by 100. 20 divided by 100 is how much? 0.2. So total number of ions present will be what? 1 plus alpha, that is 1 plus 0.2, that is equal to 1.2. Did you follow?
Yes, sir.
Yes. Now what is delta TF? Delta TF is I into KF into M. We found out I to be 1.2. KF is given in the question as 1.86. And molality also they've given as 0.5 molar. In the question they've given as 0.5 molar. So on simplification, you will get the answer to be 1.12 Kelvin. 1.12 Kelvin. Answer will be option C, 1.12. See here they've given minus. It cannot be minus. So it's plus 1.12. Hence the answer for this question is option C. Followed?
Yes, sir.
Yeah. The next question. A solution of urea, molecular mass of urea is 60, but here they have mentioned it to be 56. Since they have mentioned it to be 56, we will take it as 56 only. All right. Boils at 100.18 degrees Celsius. A solution of urea of molecular mass boils at 100.18 degrees Celsius at atmospheric pressure. If Kf and Kb of water are 1.86 and 0.512 Kelvin kg per mole, respectively, the above solution will freeze at, they're asking. You should remember delta TF is equal to what? Kf into molality. Likewise, delta TB is equal to what? Kb into molality. So concentration is same. So therefore, what happens? We can write delta TF by delta TB is equal to Kf divided by Kb. You know what is Kf and Kb? Kb is molar depression constant. Kf is molar elevation constant. Now they're asking you to calculate the solution freezing point. So delta TF. What is delta TF? Delta TF will be equal to Kf into delta TB divided by Kb. So what is delta K? What is Kf? Kf they have given us what? 1.86. And Kb they have given us 0.512. What is delta TB? Delta TB they have not given directly. We know that delta TB is T minus T naught. Boiling point of a solution minus boiling point of a pure solvent. So it is 100.18, and we know that water boils at 100 degrees Celsius. Therefore, delta TB is 0.18 degrees Celsius. So here you write it as 0.18 degrees Celsius. Did you follow this? We have not taken in Kelvin scale because they have given you in degrees Celsius. You can take it in degrees Celsius directly. Here, in this kind of problems, in case of the chapter solution, if you take degree Celsius or Kelvin scale, you'll get the same answer. So do not convert here. So what will happen? So that will be on simplification, you will get around 0.6539, approximated to 0.654, approximated to 0.654. They're asking the depression in freezing point. We know that delta TF is equal to T minus T naught minus T. T naught minus T, freezing point of a pure solvent minus freezing point of solution. So it's 0.654 is equal to 0 degrees Celsius minus T. So what will be T now? T will be minus 0.654 degrees Celsius. Here it is minus, the decrease. Therefore, the answer, not minus 6.654. Therefore, the answer is D here. The answer is D. Did you follow?
Yes, sir.
Yes. Now, I don't know whether we can work few more problems. I've solved all problems. One or two problems we'll solve. I'll write it and solve. The next problem based on freezing point, where is this? The next problem on freezing point, I'll write it in the last page here. Right. Molar depression constant, I'll write it. I didn't have time to type. Molar depression constant of water is 1.86 degrees Celsius. The freezing point of 0.05 molar solution of a non-electrolyte, in water is. Now they're asking, molar depression constant of water is 1.86 degrees Celsius. The freezing point of 0.5 molar. What's the formula? We know that delta TF is equal to KF into molality. So what is KF? They've given this 1.86. And what is the molality? They've given 0.05. So that will be equal to 0.093 degrees Celsius, 0.093 degrees Celsius. What is that they're asking? They're asking molar depression, what is the freezing point? They're asking freezing point. So what will be the freezing point? We know that delta TF is equal to T naught minus T. So TF is what? 0.093 and T naught is 0 degrees. So pure water freezes at 0 degrees Celsius minus T. So T will be what? Minus 0.093 degree Celsius. Hence the answer for this question will be, I have not given you the options. Hence the answer for this question is minus 0.093 degrees Celsius. Did you follow?
Yes, sir.
Yes, sir.
Yes. Now one more question. That's the question. I'll write the question here. I'll erase this and write. I hope you followed. Yeah, wait. No, this is not a. One more class, we'll finish with this chapter and then we'll go to electrochemistry or other chapters. Let's see. All right. The next problem is, I'll write the question. Where is that? If freezing point of a solution prepared from 12.5 grams of a non-electrolyte and 20 grams of water is 271.9 Kelvin. The molar mass the molar mass of the solute will be. The molar mass of the solute will be. So what is given now? They have given the freezing point of the solution. Freezing point of solution prepared by 12.5 grams of non-electrolyte, 20 grams of water. So they've given T. They have given T to be 271.9 Kelvin. It's in Kelvin scale now. And they've given you the weight of solute. Weight of solute is 12.5 grams. And weight of the solvent, they've given us 20 grams. They're asking you to calculate this. In order to calculate the formula, we know that it is delta TF is equal to 1000 into Kf into W divided by M into W. Now, what is this TF? They have not given you TF. So what is TF? TF is equal to freezing point, T naught minus T. So there is 273 minus 271.9, because see, they have taken the temperature, given the temperature in Kelvin scale. So therefore, you have to convert this also in what Kelvin scale. So pure water freezes 0 degrees. That's nothing but 2 more precise, 23.15 minus 271.9. So that will be equal to 1.1 and 1.15. 1.15, 1.25. We'll take it. They've taken it as 273 only. We'll take it as 1.1. So what will be M now? M will be 1000 into Kf into W divided by delta TF into W. So that will be equal to 1000 into what is Kf? They've given you Kf to be of water. Kf they've not given. The question, it was not given. So Kf is a constant. So it's 1.86. Remember. And what is W? Weight is 12.5 divided by 1.1 into 20. Weight of the solvent is 20. On simplification, you will get 105.68. So the molecular mass of the solute is 105.68. So we'll work last set of problems topic in the next class with the chapter solutions and go for the next chapter in the next following classes. All right. Madam, any clarification you can ask me.
No doubt, sir.
No doubt. All right. We'll stop the class. Ma'am, I'll stop the class.
Yes, sir.
Yes, ma'am.